Hello and welcome. I'm Bill Wake. We're here working on a Tune Similarity tool. Its scope is kind of undefined. I'm still exploring the topic, but we've been working on an ABC parser. ABC is a notation used for music, kind of a simple, well, at its heart, it's a simple notation with you just put the letters of the notes. There's a lot more around it as we're seeing. And then we're parsing that, turning it into a tune structure. And at that point, we do what we call a Parsons code analysis, which measures the up and down motion of the melody. And if you compare those patterns, you can compare the melodies. Let's see, I have an example, a picture. So on the left is a Bach march, a CPE Bach, bum, 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 bum. And the pattern of it is up, down, up, down, and then plaisir d'amour. You probably noticed I Can't Help Falling in Love. Bum, 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 bum. And it starts up, and then stays the same. And those patterns, they imply a little shape like shown on the bottom. And we'd like to eventually organize a list of tunes around their shapes and compare them and find out their similarity. All right. What we've been doing is, let me get chat going. We've been doing refactoring the last session or so. We got things working, so we parsed the note, finished parsing the notes, parsed just one song, then parsed multiple songs, and now we're doing some refactoring as I've got some things I am learning and understanding better about my domain and my code. Okay, let's see. We need to find ABC parser. All right, so the last thing we did yesterday was throw away a bunch of work. What I tried to do was separate out this make note parser, and I wanted to pull it into its own class. The problem we hit was BuildNote is a function, and it uses the current key, which is a field on the ABC parser. Now we tried moving the field over, but the problem is because it's using a functional style where we define this parser as a big function. These are function composition operators that make a grammar, and the whole thing reads text and produces notes in this function. And the problem is BuildNote. This happens very early. We create the parser, and BuildNote is going to capture the variable, and it captures it in its initial state, and it doesn't really have a way to get back to the current state. Now, the parser itself, it takes in, well, in our case, it's characters and produces a note. So there's no extra place to put information about the current state, which is maybe a flaw in the parser. It's certainly common enough to need state moving around. But from a functional point of view, it's like if you don't pass it in, you're asking for side effects, in effect. Not, well, yeah, I mean, I guess I would say it is. We're relying on external state, and we haven't dealt with it in a functional way. But our parser is all built around functional style, so there's a conflict. And I tried a few things to try and get to the current key and try and get to the current object, like specifically saying self.current key and assuming it would find the right self. It didn't work. I thought it should have, but it didn't. So I have another alternative, which is when we construct this thing, we're going to pass in the parser itself and let it own the object, the current key. And I think it's kind of a true relationship that the current key is really a function of all the parsing you've done till far, and ABC parser is in charge of that. So I'll justify it in that sense. How we get it there? Okay, well, let's see what happens after yesterday. Okay, so one thing I know we did before we reverted was we pulled these functions up to the top. and out of the class, really. They're nothing to do with they're nothing to do with ABC per se. I mean, they're very generic parsers. Look for a character, find something that doesn't match a character, look for a set of characters, look for something in a range. You know, it's okay. And I don't know, match characters. I think one of is actually a better name for this too. So let's rename this. And I probably should have started with running the tests, but we'll do that now. Okay, so we pull generic parse methods outside of ABC parser. Rename match to one of. There's still another one called match that does match one character, and I think that's okay. Wow, my clock's slow. All right, now I want to pull make NoteParser. I really would like that to be in a separate file. So let's go do that. NoteParser. And I have doubts about Note being the right name. I think I'll deal with that later, but I think in some ways Note, what I'm calling Note now, is probably better expressed as being the pitch. And the note, usually you say it's a quarter note or something like that. It's got some rhythm and maybe some, it may have other things attached to it, grace notes and who knows what else. Okay, let's take this function and BuildNote. Now pull those over. Okay, make NoteParser. That seems good. Okay, cannot find. Well, we need to import pcombo. You'd think doing this yesterday, I would have learned that. Now, here's this current key issue. Okay, and let's see how this thing's feeling. Make NoteParser. Cannot find. Okay, so let's. All right, let's create our NoteParser. I'm going to call it NoteParser main again. Is NoteParser. Okay, and this will be NoteParser main. Make NoteParser. Okay, so everything compiles except for that current key. All right, so I think what I want to do is I want to pass, well, ABC parser. I hate coupling objects so that ABC parser knows NoteParser and NoteParser knows ABC parser. It annoys me, and it sort of creates somewhat problematic situations. In reality, I don't think it's going to be an issue because all we do with NoteParser is use it to build up the actual parser. And yeah, so I'm going to say let's pass self. And we need a constructor now. Takes, well, for now, I'm going to say ABC parser. Oops. I'm gonna say state. I don't know. State's not the right word. Maybe TuneState. We'll just and we'll make a var. TuneState be an ABC parser. Oh yeah. Function. Oh no, this is init. Okay. Right. And now, instead of current key, let's do TuneState dot current key. Okay. All right. So I think we're doing the right thing. We're passing the self. We're passing ABC parser into NoteParser main, so it can get to the current key, and then down here, it's TuneState is okay if it captures because it was created. You know, it was created before that method got called. Okay, so, all right, I expect this to work. I mean, excuse me. Yeah, sorry. All right, this should work. Okay, more water. Well, okay. I mean, what did we spend 45 minutes yesterday flailing around doing it the other way? Some amount of that time was me figuring out that the current parser was not being caught. All right, I think that is an improvement. Let's see. Can we do the same thing for keys? Sorry, excuse me again. All right, so let's do a key parser. Well, let's check that in. It's green. Oh, and I think I want to refactor too. Okay, so the fact is the NoteParser only cares about current key right now. There may be other stuff it needs at some point. There may be other things other methods need, but I want to make that an interface. TuneState, I'm going to call it because that's the word I was using before. All right, and I'm going to say you must have a current key of type key. All right, I think I'm having the syntax right. And this thing is a TuneState, so there's no problem there. All right. Can I find TuneState in scope? Expected expression. Well, it's definitely not something I've done much of. Wrong Swift. Protocols. Oh yeah, we don't use the word interface. We use the word protocol. Yep. Protocols are public only. Okay, good. Okay, so protocol TuneState is current key, and we need to get it. All right, must have explicit get. Good. Okay. All right, so here's TuneState, and let's use it over here. Okay, so we're not passing the whole parser, and we're just saying, I just need access to the state. And the state we care about is current key, and that's the one we got here. Now, the reason I'm making a protocol and all that is because I expect this to grow, because I know there's also the notion of the current time signature and the current rhythm and the current this and that, so the current part. So we want to be able to update those as we go, and that allows us to do that. And even though we're passing in self down here, the stuff we're passing in is not the whole ABC parser. It's really just the interface that has those things. And, you know, and I could, and maybe I will at some point, create a whole, maybe this becomes a whole TuneState object, and that's what gets passed around. That's okay too. But I think for where we are now, this is good, assuming it all works. I think I ran it. No. Initializer cannot be use an internal type. Now I thought I just read that TuneState. I thought I read that protocols were already public. Maybe they changed something. Property current key. Oh. Cannot assign value of any tune state. Oh. Initializer cannot be declared public because its parameter uses an internal type. Well. Oh, there we go. Okay. Okay, now let's deal with the keys. And I think there's plenty of room for improvement there. We need to reference keys at various times, and I think we can make this class, this class or key know more about it. Okay, key parser. We'll need make keys. I think accidentals 4 is the key stuff, yeah. Make key parser and build key. And I'll just comment it out because it's a big chunk. Okay, so here's all this. Key to accidentals. This is one of the, okay. I don't know if I can. Let's go find the declaration. Key to accidentals. Let's find that text. We make the map. I think we might be able to move that field over. And then we'll need this in our constructor. so we make the map. And is everybody happy in here? Yes. Okay. So now we don't need this anymore either. And we'll make a key parser. Maybe builder would be a better name there. Key parser builder equals key parser. We don't need self yet anyway. And then this is key parser builder dot make key parser. All right, how's everybody like that? Good. Okay. Extract key parser. And we'll clean up a little. Oh, I guess I had all that commented code here. All right, let's take all this. Okay, refactor, delete commented code. Okay, and then, that's kind of a top level entry for this. This is as well. Let's call this reference number parser. I don't know. The X is part of our file format, and I don't know that I want to mention it here. Build reference number. Title parse it. Okay. I don't know if the, let's see, does this notes thing justify? We'll see who uses this. Whoops. Find selected symbol. Okay, ABC parser Swift defines it. Test use it. Okay, yeah, that's kind of an well, I think there's ambiguity in how I'm using things, but I sort of feel like I should give you I don't know. Maybe this is not my initial thing was that I'm going to take whatever your input is and parse it and then ask you for the notes, and you would give me back a notes object. Let's see. Yeah, a notes object. And then I would apply the analysis to the notes object. So the parser domain does all its stuff and it gives me back notes, which is in my domain. Okay, so let's make sure everything runs. I changed did some renames. Okay. Now I'm going to deal with note, I think. MIDI note number is probably an okay name, but I want to change this to pitch. Okay. Note name, that's okay-ish. I don't know if string is the right choice. We ran into places where you wanted character a lot. All right. Yeah, I I think that's actually okay. The colors might be a little using the word inconsistently a little bit, but note becomes pitch. Now the place, okay, this is where I'm not, I don't know. The fact, like how you get the keys you get, I don't say this. The key signatures, let me find this again. Pitch. We had the key. There it is. Okay, so what we've encoded is this column, well, the major column, C sharp, F sharp, and so on. And the fact that 0 sharps is C and 1 sharp is G and all that stuff, that's clearly in the music domain. It's not an artifact of the parsing. It's the way the keys work. I mean, kind of the fact that the way this works and all that is kind of like the big accomplishment of, you know, Western music theory, was kind of realizing like, oh, we can make all this go. And like Bach was a big proponent of what they called equal temperament, which made all this stuff sort of work out from a sound perspective. It's a compromise, but you know, that's okay. It works out nicely for a lot of things, and there are a lot of patterns. So notice this C G D A E B F. If I go the other way, well, it's a reverse. So F B E A D G C. Okay, so it wraps around basically, and there are all kinds of little symmetries you can find and things like that. Let's see. Yeah, so our code, I mean, it knows that. It knows the notes are by fifths, and it knows to make these key signatures. The part that's funny is the key names. And I don't know, maybe what happens is people give us B, meaning B flat, and we're supposed to say, oh, the key of B flat, that is two flats, B flat, E flat. Okay, and we're supposed to know that E flat is 4 flats, B flat, E flat, A flat, D flat. I think I'm doing that right. So these symbols they're from our input file. They're not any kind of musical thing. But I think so it makes sense to me that somebody's got to do a mapping like this, and that's okay. But like all this, I don't know. I think we want to have our keys. Okay, where do we make a key? Accidentals 4, that's okay. But I think this method should maybe move down a little. Okay. I want to get this stuff pushed back into key. Key should know all this stuff. Key to accidentals, string to an array of pitches. Okay. I mean, what I want to do, let's see. Let's make sure we understand the calling order of all this. Okay, make keys is called by these two. All right, yeah, so this process, I feel like it should be a static thing on key. All right, let's bring up key. Okay, so keys equatable. I don't know if I can make a static. Sorry. An unhappy toddler, sorry. Okay. All right, so I'm not sure how you do that here. I guess they must have the static stuff just like they do for classes. I mean, I just haven't done it very much. I don't create a lot of statics, frankly. All right, but I want to get this done over there. So the thing I want, like, what are you going to give me? You're going to give me, I think you're going to give me a note is what this boils down to. And I'm sorry, the input here. You're going to give me a key name, and I'm supposed to give you a key. Well, actually, it would behoove me to just give you the whole key. I guess I'm going to build, well, I don't know, that chart has a lot of columns. What's the right way to do this? So somebody says C# mix. I should somehow say, oh, that's the 6# key, and know how to do that. Okay. And somehow, like, maybe, do I need to know this? Maybe I should be keying off of the number of sharps and flats. So what's my map? Is my map C# or C# maj, or A# M or A# min, or G# mix or D# door, or so on? All those are indexes that lead to 7 sharps as my description. And then over here, I have something that indexes by sharps and flats. I don't know. Okay. Yeah, this is not a straightforward kind of move refactoring, is it? I think I need to put stuff in place. I don't know, does this thing mean anything? This key signature. Like, I could have a table that says 7 sharps and then tells what they are. That's a good thing to know. And then, yeah, maybe that's the thing to know. If you ask, maybe I just tell. I don't know if the mode comes back in. Okay, so if I gave you a number and an accidental, then you should give me, oh, let's see, if I give you those things, I should be able to give you the accidentals for that key, that knowing that 1 sharp is always F#, key of G, or E minor, or this or that. All those things map into it. These words, they are definitely concepts in the input file format. The column names, Ionian or major or equivalent, Aeolian or minor or equivalent, and so on. Those are musical terms. Okay, they call it the classic 7 Greek modes that the Greeks identified, back when. Okay, so I guess what I'm saying is I should be building a map that is number accidental. I guess that's a key signature. Goes to a list of the things that it has, the list of things in that signature. The pitches there. Okay, so let's see. What I've done here is I've just directly done it. Okay, so what I'm saying I want to do is I want to create key signature to accidentals. Its type is, I guess there's a key signature type. Well, I'll assume it into existence, I guess. And it's a list of pitches. I don't know, pitch maybe not right. Okay, let's make one. I guess it's really a struct. There's nothing to it, really. Int number var number of int and var accidental of accidental. Okay. Starts empty. Whoops. Okay, and then key signature does not conform to hashable. I don't know if I have to do any work for it. Simple types, or is accidental hashable? Okay, so if I put in, let's put in C. Okay, so let's do key signature to accidentals. Let's give this thing a constructor. I worked a little in IntelliJ last night, and there is definitely stuff I miss. Okay. Let's see. So this, okay, this sub key signature 0, let's call it natural, equals empty array. And key signature of 1 sharp is pitch F Note name accidental and optional octave and key. Okay, let's do sharp 5 is actually where it goes. Okay. Now I need to do all of them, but we're still green. Oh, Alexis, hi, nice to see you. Let's see. I can give you a little background. We're doing a program to compare this similarity of different tunes, like fiddle tunes or something, and we have what we call Parsons code, where you can kind of like just get the contour of the melody based on ups and downs, and then I want to kind of make plots like this. Well, these letter form or the plot form, and then I can do some analysis to say, what's the gap between these two. They have some similarity, but there's a gap, and we can sort by them and do that. And then I want to keep going on different analyses. Like I feel like DNA analysis looks for similar strings and matches them up, and all that stuff looks for patterns that move around. It ought to be useful for this kind of analysis. So the way we're doing it, so this part is pretty easy. If you know the notes, you can tell if it's the same or different or up or down. Okay. We're working with what's called ABC notation, and let me get down to the examples. Section 13. Okay. So the core of the note stuff, this is all kind of like file header, tune header, and then you get in here, the notes are B, C, D, B, A, G, bar line, F, A, A, C, B, A, and so on. They're all kind of there in letter form that a human could write, a dedicated human, I guess. Or there are programs out there that will generate this notation. So we're trying to parse it, and right now we can read the X lines, the T lines, the K line in restricted form, and the notes in a restricted form. And I'm trying to get the musical. I'm trying to get the knowledge of key signatures over into the key class instead of the parser knowing all about it. Okay, and so what I want to do, I'm trying to design the structure that's going to go over to the key eventually. But let's see. So I have the beginnings of the table that tells me how many sharps, what are the pitches for various sharps. This actually computes that as well. So I probably can do that. Yeah, but I'm kind of rearranging the indexing. Let's see if I can find my pitches again. There's a table of keys somewhere up here. Up here, I think. Yeah, there we go. So I'm trying to encode this table, and my approach is going to be, you tell me C sharp, A sharp M, G star mix, and so on. And the parser is going to know how to get from this name, which is not a musical name, to the key signature, which is a musical concept. Now, there is also this notion of the mode. I don't think we have anything that relies on that. So we'll do with that. But today we just go from this name, C sharp, F sharp, and so on, to the list of sharps and flats. I'm trying to put an extra layer in the middle that my musical stuff can do. Okay, so let's see. So I'm defining the key signatures by number of sharps or flats, and then I need to map. These names into those. Okay, so I think. All right, so C key signature. I don't know, I'm making these all key signatures things, and I don't think I need to do that. I don't know. I get lost. Okay. Now, really, I need to bring this table in, and it needs to talk about all 7 sharps and flats and so on. But I think I can say all key signatures is an array. What does make keys do? Make keys. Okay, I don't know when that. Let me pull this out. Okay, make sure I'm still green. I don't think I've done anything that could break anything yet. Okay, so make keys produces, oh yeah, we get string to pitch is a pair. Okay, and then the table builder, the dictionary turns that list into that. Okay, so the dictionary is string to pitch, string to array of pitch. Okay, so if I said var result is type string to array of pitch, okay, and it starts off empty. Okay, and then if I say add to it, well, I guess one thing I'm saying is result of C equals key signature to accidentals of key signature 0 natural. Okay. And result of G is key signature to accidentals, key signature 1 sharp. Okay, so I'm building a map. This is more the parser domain. The named string C should, we know that it maps to 0 natural. Okay, is that what I want to do? Maybe that's what I need is, let's not call it result. Let's call it key name to signature. Okay, and this is not, it's a string, but it's going to be to a key signature. Okay, and then this, let's take that out. Okay, this is better. Oops. Okay, that feels right, because this is something the parser needs. And then the result is a dictionary. Well, the result is this type. Okay, I'm changing this around clumsily, but I'll get there. Okay, var result is string to pitch. Starts out empty. Okay, now I'm going to say key name to signature dot for each, and I'm going to say result of well, what do I get from this? Let's do dot keys for each. Okay, so this is a key name, and I'm going to say result of key name equals no, I think I get a pair like this. Is going to be key signature to accidental sub signature. Does that look right? And then we return result. And I'm not sure. Okay, now I'm changing behavior on things. I'm not sure if my tests really test all these key signatures. Let's see. That should build. Yeah. Okay. Let's see. I know I use C and G. I may use some others. I may have to fill some in manually. Okay. I've got the shape. Oh, I do have failures. Okay. Single letter. Oh, I do test them all. Okay. But I think I can. All right. I think I can do this now. I'm going to say, how can I do this? Oh, it's one. Yeah. F, C, G, D, A, E, B. Is that the list I had down here? F, C, G, D, A, E, B. Okay. Yes, this is the notes by fifths. Is that. Okay. So the reason we say fifths is because we're going up by 5. F, G, A, B, C, C, D, E, F, G, G, A, B, C, D. Okay. Oh, the wraparound on A, you know, the way we do musical names. Okay. So I have the notes by fifths. If I were to take the notes by fifths, okay, and for each, I'm going to do something. Well, what am I going to do? This one's free. That's C. Okay. But this one, I want. Okay. And I think I want to do dot enumerated. For each. And I should get the note count in. Okay. And this count is 0 base, so I have to do count plus 1 sharp equals pitch of note name, let's call it, sharp. And I'm just going to leave this 5 for now. That's the octave choice. Did I get them backwards? Enumerated array. In C. And is the number. Okay, so I go backwards. Okay. F, C, G, D, A. Let's see. F, C, G, D, A. I think is a 4. Okay, but this gives me. All right, that should give me all my key signatures, all my sharp key signatures. Then we can do it the other way around if we reverse them. Okay, because as I mentioned, the flats come in the opposite order. Okay, so I'm going to do that reversed. Enumerated for each count note name in. Okay, and then this. Okay, key signature and count +1 again. We're doing the flats. Pitch note name. Flat. Okay. Now, that may get us some more passing. I don't know. We might have to fill in all these. Yeah, single little sharps. Okay, yeah, we only map the first two, so these aren't going to get it until we do that. Okay. All right, now let's do the same kind of thing here. We have the key names. Okay, so these are the sharp keys. Dot enumerated gives me the count and the key name in something. And then what am I going to do? Well, I'm going to do something like this. The G is the key name. And this is count +1 sharps. Okay, and let's see how we do. I think our sharp keys should be working. Build failed. Oops. Oh, dot for each. Okay. Single sharp keys. D has 2 sharps. What am I doing wrong here? This is 0 goes to 1. G has 1 sharp. Well.
I'll be right back.
Okay, key name to signature key name.
See? I need you, please.
So I'm not seeing it. So G comes in with count 0, key name G, key signature is key signature 0 + 1 sharps, which is correct. D comes in, well, instead of speculating, let's just run this test. Okay, so let's look at key name to signature. A little complicated, but okay. where did she go? Oh, there it is. Okay. I guess it's a hashed function. We don't know what it's going to come through. D is 2 sharps. F sharp is 6 sharps. A is 3. That's right. E is 4. G is 1. C is 0. C sharp is 7. And B is 5. Okay. Those all sound right to me. Okay. So key name to signature for each. Let's step over this. And let's print result. Another map. Result maps C to nothing. Right. A has only one accidental. G sharp. Have I? Oh, I didn't accumulate them right. Okay. Key signature. I guess this is why I did make keys, huh? Key names are a string. All right. Well, the fact is, this only gives me 1 sharp for each key, and they should be an increasing number of sharps. So I'm not computing the key signature right. I've got all the tests for it, so I'm trying to do this from the outside with those tests, but maybe I'm just stumbling too much here. This thing gives me a string to a list of pitches. The string is the key name. Well, I don't care about the key name so much. It gives me an array of those in order. Okay, let's see if we can call make keys. Okay, so key signatures, notes by fifths. I want to say make keys here. Make keys. Key names are notes by fifths. Not really caring about the key names. And the accidental, these are the sharp keys. And the order of accidentals is notes by fifths. Okay, so this is it's really like I'll say accidentals in order is that. Okay, and that is string pitch. We don't really need the string, so let's let's map. Well, let's zip them together. Is that right? No, I think I can just take accidentals in order. So the first one should be F, the second one should be FC, and so on. Okay. If I enumerate those for each, I have count, and make keys is string pitch. String pitches. Okay. In something. All right. String pitches. Oh, is it? It's an array of string and array of pitches. So string pitches. Okay, can I don't think I can do that. Okay, I got to do it here. Let nothing pitches equals string pitches. Okay, I think I'm in shape here. All right, so the key, let's take this. Key signature count plus 1 sharps should match to pitches. Okay. I think that looks better. And in which case this is redundant and this should pass some test. Okay. Kill the breakpoints and continue. Okay, the sharp keys, yes. Single letter sharp keys works. Single letter flat keys does not. Let's do the same thing here. Okay, so this goes away. Now we need the this is really sharps in order. Okay, and we're going to do the same thing for flats with notes by fifth reversed. Notes by fifth dot reversed accidental is flat, and this is reversed. Actually, this doesn't need to be reversed. Okay, and this is flats in order. Okay, we get string to pitches, count plus 1 flat is pitches, and then this is redundant. Okay, I think we don't have any flat keys in our list yet. Okay, yeah. We need to do the same thing here. This. Okay, so just like we did that for the sharps, we need to do this for the flats. Count plus 1 flats. Okay. Here's where I expect it to pass. All right. Still awkward and ugly, but okay. So we changed the approach to key signatures, split apart the number of sharps and flats from the key name. And I guess that's probably, I probably should put that in our to-do. Okay, so we did a bunch of refactorings. Let's capture that. rename note to pitch, extract note parser, extract key parser, and miscellaneous renames and code motion. Okay, now I would say we are change key signature to split number of sharps and flats from the key name. And we're still kind of in the middle of that, but we're through the hard part. Okay, let's see, key parser now. We don't need this. Okay, so we know our notes by fifths. We key signature accidentals. This part, let's see, key signature to accidentals. Yeah, that I want to move to the key. And then key name to signature, that's a parser issue. Okay, so let's pull this over first. And I don't know if this belongs in key or not, but I think we'll pretend it does. Okay, for now anyway. Then this, key to accidentals, key signature to accidentals. Yeah, this is the thing I want that to know. Okay, I'm going to pull this over. Wait, I'm going to pull make keys over as well. And I'm just pulling a copy. Where's the right thing to put this? I don't know if I can do an extension. Extension on key. Let's pull this stuff. Okay. All right, that's somewhat self-contained. We don't need this. Okay, let me do the same here. Make sure it still works. It shouldn't be an issue. We're still doing things the same way. All right, so we're going to say start moving key signature over to key.swift. Okay, I guess what I would like is that I would like this to be a field I'm going to have to put it up here. And I want it to be static. Okay. Is that okay? That's key signature to accidentals. Okay, so this is that okay? Oh, I probably have to say static member insert key dot. Okay. All right, we're building. Okay. So what I want to do, okay, I want to make, all right, I'm going to take these off. Make sure we're still okay. I'm going to make this static. And then I'm going to make this static. String to pitch. And that's the same type as, no, it's not. I want this to produce, oh, I should have left that. Var key signature to accidentals of type key signature to array of pitch. I shouldn't have put those in. Okay, so I think variable key to signature accidentals passed by reference before being initialized. Let's rebuild that. Passed by reference. Well, I don't know why it's considered by reference. Key signature accidentals. Okay. All right, now key signature accidentals. The name to signature stuff I don't need. That's the other part. But I want to return key signature to accidentals. And then I want to make this. Oh no. We still say that. Okay, key signature. Okay, the parser needs a string. We need key signature. Okay. Then I want to call this. And he takes nothing as an argument, right? Yeah. Okay. I think I should be building this structure up now. Okay, so we make key signature to accidentals as a static on key. Now, I don't know if that publicly available is the right way to go. But okay, so I think what we have is when you create key, you also create this key to accidentals map, and we got cleanup to do, but it's producing the right notes in there. Okay, we don't need this anymore. Okay, so it's producing the right map from 0 to 7 sharps or flats. Okay, 0 you have to say natural, but all right. So let's Actually, let's add a little extra. Let's make sure we don't care which way it is. Okay, that shouldn't affect anything. Okay, now I've got this structure sitting around on my key class, and it can answer the question, well, yeah, maybe I need to say key for key to signature. Key for, and you give me a key signature, and it returns an array of pitch. Right? Yeah. Okay, and we're going to return this thing. Sub key signature. Okay, and I guess I'm going to make it your problem to check it. If it doesn't come back, that's a parser error of some sort, and we'll let it deal with it. Okay, so now if you say key.key for, well, maybe I can just call it 4. Of. Okay, let's try that. Now, KeyParser, I think all this stuff down to here is covered by that. And somewhere there's a reference, key signature. Okay, this now should be key.of the signature. Yeah. Key.of the signature. Okay, is that what I expect? Okay. And then all this has been moved over, so let's take it out. Okay, so we are building up a name to key signature map. We make that. Nobody references this, I don't think. Nope. We have a corresponding function over in key, or we moved it to key. All right. This thing now, where's this done? Okay, at the start of KeyParser, it builds up this map. And then the KeyParser uses it. Oh, and here it accidentals for. It uses our key to accidental thing. If it fails, then it returns key of C. Let's make sure this all works. Good. Okay, so now key signature, number of sharps or flats is owned by key. KeyParser has a map from its names to key. Signature and gets the key from key. Okay. Let's check this code. So there's the of. Whoops. Okay, we added a couple. Deleted that. Okay, we deleted that. We deleted that. Kept that. Use key of. Good. Good. And then key now has key of. And what else? And we added flats and sharps because whatever you use, it's going to be, whether it's zero sharps, zero flats, or zero nothings. Like zero is kind of a weird case, right? All right. This looks good. Okay. And move to key. All right. I think we've done that. Okay. All right. Well, that's kind of what I'd hoped to finish on refactoring. I think next time we'll go back to the Parsons code, and really the challenge. Well, we'll have to deal. We want to deal with the codes for a whole file, yes, and we want to deal with drawing them. And what I see as the challenge here is like making a little graphical. I want to imagine a kind of a grid where I can start and then go up, 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 and the system will kind of expand it as needed to hold what it needs to do, up or down, and then kind of sort things by the Parsons code. So we'll do that, and I think that will get us. That'll get us a good point. We don't handle the full arbitrary stuff in keys and notes yet. I think we will try and do that starting tomorrow. Well, no, I'm going to focus on the Parsons code. That's probably a session or two. But we'll get that going, and then go back and make sure we can handle arbitrary notes. I do. Fiona Potts, that has this big article on the variants of no scale and decahals, is going to get me an ABC file for those, and so I'm hoping we can use that as the whole code example and see what we get out of that. Get her some information about which variants are more similar. So I think that'll be fun. All right. Thanks for joining. I hope I catch you again in the future. Tomorrow today I have a doctor appointment, so I had to cut short. Normally it's 1 to 3:30 p.m. Eastern time, or UTC is 6 to 8:30 p.m. and Monday through Thursday. So tomorrow we'll have a session. Thanks for joining. Take care. Bye-bye.